Check this out. We've got something really fun today. This is so amazing. Oh man, again? 1.1 Arithmetic Sequences. A sequence is an ordered list of elements or terms. For example, 1, 2, 3, 4, 5, 6 is a sequence. A finite sequence has a limited number of terms. It has a first term and a last term. The first term of the sequence we're going to call T subscript 1, but some textbooks use A. The number of terms is n, and the general term is T with a subscript n. An infinite sequence has an infinite number of terms, so it has a first term but no last term. We are going to be only interested in sequences that have a pattern. Let's look at these next few examples and try to identify the pattern and list the next three terms in the sequence. So this first one is 2, 3, 5, 7, 11, 13, 17. And what's the pattern? Well, these are all prime numbers. So the next three terms in the sequence would be 19, 23, and 29. What about this one? 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. This one's known as the Fibonacci sequence. It's recursive, meaning that in order to find the next term, you need to know the term before it. And the pattern is that you just add together the two preceding terms to get the next term. So 2, and then 3, and then 5, and then 8. And this is a great fun sequence that we see in nature. The next one is 4, 8, 12, 16, 20. And this one we would add 4 each time. So the next three terms would be 24, 28, and 32. Now, when the difference between consecutive terms is the same, the sequence is an arithmetic sequence. Now, that word is also pronounced arithmetic under different circumstances, but as soon as it's a sequence, we call it arithmetic. This constant is going to be called the common difference, and we're going to use D to denote the common difference there. And we find the common difference by taking any term and subtracting the preceding term. So 20 minus 16 is 4, or 24 minus 20 is 4. And of course, it doesn't matter which two terms you're working with, the common difference will always be the same. The formula to find any one of these terms is going to be called the general term. And we call it T subscript n. We want to find the general term, for example 1c, and use it to determine T100. Now, it is possible to count by 4s to this 100th term, but that would be annoying, take lots of time, and we might make a mistake. So let's look at the pattern for these arithmetic sequences. First we have T1. Now T2 is just T1 plus the common difference. T3 is the T2 plus the common difference, and so on. So T4 is T3 plus the common difference, and hopefully that's enough to see this pattern. We're always taking the last term and adding the common difference. Now, if we look closely though, T2 is equal to T1 plus D. So for this one, we could say this is T1 plus D, see that, to replace the T2, and then plus this D. So this D comes from here, and this D is right here. So actually we get two D's here. And we can do the same thing for this one. T3 is actually T1 plus 2D. So let's replace T3 with this. So we got T1 plus 2D, and then the plus D from this right here. So actually T4 is just T1 plus 3 common differences. Now this makes sense because we started here and we went 1, 2, 3 common differences up, and we got T4. So our actual general term is Tn It's representing any term here, the nth term, and
we'll start with T1.
And then we are adding always one less common difference. So this one is term 3, so we're adding 2 common differences. This is term 4, so we add 3 common differences. So this is term n, so we add n minus 1 common differences. So this is the formula for an arithmetic sequence. Let's specifically apply it to this example 1c. So we'd have our Tn is equal to, in 1c, our first term was 4, and then we're going to add n minus 1 common differences, and the common difference in example 1c was also 4. So there's the equation for our general term. Now we can rewrite this and simplify, maybe multiply in the 4 here, and it's okay to leave it like this though if you prefer. You could multiply it in, so we get 4n and then minus 4, and 4 minus 4 is just 0. So actually this one simplifies to 4n. Now we'll do our T100 here. So T100 is equal to 4 times 100, and in this case our 100th term is 400. Given the sequence 2, 5, 8, 11, determine the value of d and the value of T201. So first let's find d, and d is the difference between any consecutive term here, so 5 minus 2, and that would be 3. You could have done 8 minus 5 is also 3, or 11 minus 8 is also 3. The next thing is we want the general term, so Tn, and we're going to use that to find T201. So this is T1, just 2 in this case, plus n minus 1 common differences. And this looks fine. Again, we can rewrite this if we want. So I could write it like Tn is equal to 2 plus 3n minus 3. And this simplifies to 3n minus 1. Now, this looks a lot like y equals mx plus b. So keep that in mind. That will be helpful in thinking about these arithmetic sequences. Let's find T201. So T201 is equal to 3 times 201 minus 1. And multiply out this, subtract that, and we get 602 is the 201st term. Now if you think about these as linear, then the b would be like your y-intercept, and that's kind of like t0. Now that being said, there's no such thing as t0. Okay? When you run a race and you come in first, you don't come in 0th. Okay, so terms start at 1 and count from there. So this would be like a y-intercept or t0, but there's no such thing. Also, the common difference here is going to be like our slope. Nancy is cutting some ribbons into different lengths. The lengths of a group of 6 ribbons form a sequence. The lengths of 3 shortest ribbons are 15, 21, 27 centimeters respectively. What is the general term for this sequence? So we can see that there's a common difference here, and we could write it out. It's easy enough to see it's 6 though. And we could write the general term then is Tn is equal to the first term, this would be the smallest, plus n minus 1 common differences. And again, I'm just going to clean this up a bit, but it's okay to leave it like this. This is a functioning equation. So Tn is equal to 15 plus 6n minus 6. And Tn is equal to 6n plus 9. And that looks good. Just remember this is our common difference, and this would be as if we had a t0. It's 15 minus the common difference of 6 would give us 9. But there is no t0 and there's no y-intercept for sequences. What are the lengths of the other 3 ribbons? So we just need to add 6 each time. The last one there was 27, so the next one would be plus 6 is 33. plus 6 again is 39, and plus 6 again is 45 centimeters. If we sketched the graph of the term number versus the term, what would it look like? So let's try that. The first one we had, term 1, is 15. The next term we had was 21. The next term we had was 27. The next term we had was 33. And the next term we had was 39. And the next term we had was 45. And you can see how straight this is. What would it look like? It looks linear, and it is. And it's not continuous, it's discrete, meaning that we don't want to connect these because there's no term 1.1 and 1.2, there's nothing in between. And there's no term 0, so there's no y-intercept, as we said before. And the slope is 6, which is the common difference. Now we're given the first and second and third and last terms, and we want to know how many terms are there. This one's possible. I mean, we could figure out the common difference and then keep subtracting it, but again, it'll take a long time and we might make a mistake. So let's find our common difference first here, 136 minus the preceding term, and we get that the common difference is actually negative this time. That's why we're going down 5 each time we progress a term. So let's set up our general term. Tn is equal to the first term, 141, plus n minus 1 common differences. Now, we actually know the last term is 21, so we can put that in here for Tn and then solve for n. It will tell us what term 21 is. So 141 plus n minus 1 times negative 5. Okay, and now we just do some algebra and solve for n. So let's subtract 141 on both sides. And we get to negative 120. Divide both sides by negative 5. And we get 24. And then add 1 on both sides, and we get that n is 25. So there are 25 terms in this sequence. In an arithmetic sequence, T4 is 5 and T8 is 53. And we want to find first the common difference. Now, we weren't given 2 consecutive terms, so this is a bit trickier. But we do have 2 terms. We've got T8, and we can find how far is T8 from T4. And that should be 4 common differences, so I'm going to divide their difference by 4. So we have 53 minus 5, and I'm going to divide that by 4. So 53 minus 5 gives me 48, and when I divide that by 4, I need to move 12 up each time to get from 5 to 53. Now I want the first term, and if we just think about this, really the first term is the fourth term minus the common difference 3 times. So just do this. And T4 is 5, and this would be minus 36. So our T1 is negative 31. And we want to find the value of T18. Now we have the common difference and we have the first term, so we can put these together and write our general term. It would be Tn is equal to T1, negative 31, plus n minus 1 common differences of 12. And now we'll just put in 18 for n, and calculating all of that, we get that T18 is 173. Now there is another way to do this question, and it involves manipulating this arithmetic sequence formula in a different way. So let's look at what we've done. usually we have Tn is equal to T1 plus n minus 1 common differences, but there's really no reason why we had to start at 1 and thus subtract 1 here. So we could just have Tn is equal to some term here plus n minus m common differences to get from Tm to Tn. So this equation would work well for a question like this. Let's see how it would work for part A. If we had Tn, let's call that 8, T8 here. So T8 is equal to T4 plus 8 minus 4 common differences. You can see that from term 4, there's going to be 4 common differences to get to T8. Now let's put in the numbers. So 53 and 5 and, well, 8 minus 4 common differences. So subtract 5 on both sides, we get 48 and equals 4d. Divide by 4 on both sides and we get that d equals 12. Let's try it for part B. We could solve for T1 and we have T4 given, so I'll make that my next one. And we've got 1 minus 4 common differences here. Let's put in the numbers we know. We're trying to find T1. We have T4, it's 5. We have 1 minus 4 here, that's negative 3. And we have the common difference of 12. So T1 is equal to 5 minus 36. So T1 is equal to negative 31, which is exactly what we got here, just using logic. This was part of Relations and Functions 9, Analyze Arithmetic Sequences to solve problems. Here's some questions to try out. See if you know what you're doing.